All right, guys, this is Ms. Carballo, and today we're going to start a new topic, solving inequalities, and hopefully you will find this useful to like work at your own pace today. So fast forward my voice if you need to, rewind, pause, slow down, copy down stuff, whatever you need to do to make this the best for you, okay? All right, so we're going to talk about inequalities today, and writing them. An inequality is just a relationship between two expressions that are not equal to each other. So there's no equal sign in these. It has the following symbols: greater than, less than, greater than or equal to, and less than or equal to. So those are all in the inequalities. So these are examples at the bottom. -4 is greater than f. That's an inequality. X plus 6 is less than or equal to -23. That's an inequality. Oops. And 10 is less than 2x minus 5. So all of these are inequalities, okay? Hopefully you remember some of them from last year. The symbol is less than. Remember, if your teachers taught you like it makes an L, kind of, that's the less than symbol. It always points, the pointy part is always at the left side. And other phrases you might hear is less than or is fewer than. The greater than symbol has the alligator mouth open to the left, right? And that's is greater than or more than. Less than or equal to you can also say at most or no greater than. You will use this symbol, and then greater than or equal to, you might see the words at least or no less than. Okay, so no less than, that goes with greater than or equal to. All right. So let's look at graphing them. So inequalities have many solutions. The solution is just the answer, whatever we can put in for x. The graph of an inequality shows all of the solutions on a number line. So if I was graphing the answer to an equation, I would just have one point, right? X equals 4. I would have a point on the 4 on a number line. But for inequalities, we have to shade in multiple numbers. So we have an open or a closed circle that represents that whether that number is included in the solution set. So an open circle is when it's not part of the solution. So it's like a shield that blocks out that number. That number is not a part of the solution. So whenever you see a greater than or a less than symbol. So here's an inequality. G is less than -1. And it's an open circle because that -1 is not included as a solution. I cannot put -1 where the G is to make that inequality true. So I don't want to include -1, but I want everything less than -1 to be included on my shading, my arrow. So I shaded this way. A closed circle is when you want the number to be a part of the solution. So I think of it as like a black hole in space that like sucks in the number. The number is part of the answer. And you will see these two symbols. That means you got to have a closed circle because I want -4, sorry, to be an answer, right? So -4 is greater than or equal to -4. Yes, that's true. So I shaded in the -4. So first you decide open or closed, and then you're going to draw an arrow. So for this one, it says y is greater than -7. If I put a -7 in for the y, this will not be true. -7 is not greater than -7, it's equal to it. So I want an open circle to be there because I'm shielding it out. It's not part of the solution. And I want to shade all my numbers. So here's my variable. My arrow goes in the direction that I can put all the numbers into that variable. I could substitute it in and it would be true. So like if I put a -8 here, -8 is not greater than -7. So I don't want my arrow going in this direction. So my trick is if the variable is the greater side of the inequality, your arrow goes to the right. If the variable is the smaller side of the inequality and it has the point sticking at it, your arrow goes to the left. So I've talked about this. Solutions are any number that makes the variable a true inequality statement. So like -1 is a solution to x is greater than -3 because -1 is greater than -3. So that's a solution. And there are many solutions to inequalities. For example, tell whether each number is a solution of x is greater than or equal to -7. So here's our number line. As you move to the right, the numbers get bigger, and as you move to the left, the numbers get smaller no matter where you are. So I need all the numbers that are greater than or equal to -7, so that's -7 right there. And all the numbers that are greater than that are to the right. So -9 is not greater than -7. That's not a solution. 0 is right here. Is that greater than -7? Yes. 14, yep, that's way over here. That's greater than -7. This has a line underneath, which means -7 is a solution because it's equal to it, right? And then -3 is right here. So yep, that one works too. All right, tell whether each number is a solution of y is less than 32. So I need all the numbers smaller than 32. Well, that negative is definitely. Nope on the 41. Yes, 31.9 is smaller. No, 32 is not smaller, right? It needs to be smaller. So 32 is not a solution. It's not the answer to this inequality. And -1, yes. 8 is less than or equal to y. The y is on the right side and it's the greater side. So I need basically to circle the numbers that are bigger than or equal to 8, greater than or equal to 8. So 7 is not greater than, -7 is not greater than 8. 8 is equal to 8. -8 is not greater than, but 14 is, and -14 is not. Okay, so you're going to draw a number line, and you're going to place an open circle or a closed circle. The closed circle is for greater than or equal to, less than or equal to. An open circle is for greater than or less than. Your arrow goes to the right if the x is the greater side. Your arrow goes to the left if your x is the smaller side and it has the point sticking at it instead of the alligator mouth. Okay, these were steps to solving an equation. Draw a line, distribute property if needed, combine like terms on the same side if needed. You don't always have that step. Get variables on the same side by adding or subtracting on both sides. And then get constants, the numbers without the variables, on the same side by adding or subtracting on both sides. And then you do reverse order of operations and work backwards. Same steps for, so this was like one of the problems we were doing for equations. It's the same steps for inequalities. It's the same steps. We're going to solve the inequalities the same way. So for this equation, I would subtract 6 first. I'm going to do the same thing for this inequality. I'm going to subtract 6 first. And that leaves me with -27 equals 3b on the equation. And this leaves me with -27 is greater than 3b. Then I'm going to divide both sides by 3. So because that's the number in front of the variable, right? Same thing for my inequality. So far, I've done nothing different. -9 equals b. That means that the equation only has one answer. It's -9. For this one, -9 is greater than b. So my answers are any numbers that are less than the -9. So -10, -11, -12, right? The only value for b in the equation is -9. But for the inequality, I have many answers, right? I have an open circle, and my arrow needs to go to all the numbers that are smaller than -9, which is to the left. Solving inequalities, same as solving equations, which we just finished that unit. So this should be good, except for one special case. One special case. So let's talk about this one special case in the next video. We'll do that.